I noticed that the last two podcasts on Bill Gates' book, How to Avoid a Climate Disaster, I didn't turn on the headphones, so it took the sound from the computer audio. Seems okay, but if you have any trouble with it, send me a message and maybe I can re-record it. Okay. This is a book called The 100% Solution, a plan for solving climate change. Has a couple of different perspectives, so I'm adding a podcast on it by Solomon Goldstein Rose, a Canadian politician, I think. But it doesn't matter the author's background, as long as they did enough work to write something coherent. I'm going to use them if they have a different perspective. So this is the schematic of a bus carrying people, almost looks like a school bus. So let's imagine that the future posterity is riding down the hill because of our climate action, our impact on the planet and the climate. So it says reducing emissions is easing up on the accelerator while still pressing it. So you are slowing down the acceleration, but you have not stopped it. Eliminating emissions is taking our feet off the accelerator entirely. And reducing atmospheric CO2 levels is stepping on the brake. So obviously it's arguing that we need to not just reduce or eliminate emissions, we have to actually actively start reducing CO2 emissions or draw down carbon capture and utilization or carbon capture and sequestration. So the book imagines 5 pillars. So starting with electricity generation, we will see that in a minute. Next slide. Everything comes down to electrifying whatever that can be and then taking out carbon from sources that cannot be electrified. So energy and non-energy kind of things. Electrification itself is the second pillar. Synthesized fuels, so this is new, where in addition to renewables there is an imagination or there is a proposal here to use CO2 drawn down to make synthetic fuels. So for example H2 fueling stations as imagined here. Non-energy shifts, so that is the processes that are about sequestering CO2 that from sources that cannot be electrified. And after doing all that, you still have many CO2 sources left by 2050, and sequestration is argued to be critical for the removing the remaining CO2. So the 5 pillars to solving climate change 100% are: deploy clean electricity generation, electrify equipment that can be electrified, create synthesized fuels for equipment that can be electrified or isn't electrified by 2050. Implement various non-energy shifts. We will see what that means. Basically food production and afforestation, etc. Make up for the remaining emissions and get to negative emissions using sequestration. Okay, so here is the current system with all our fossil fuel usage and emitting plenty of CO2. Bill Gates' number of 51 gigatons is a good number. Efficiency, reduced demand for CO2, and then new system where electricity from renewables is basically removing all CO2. So it's kind of a good way to think about it. Not completely unique, but just a slightly different angle. So what are the things considered? The size of these boxes here are considered the relative percentages of the emissions reduction required from them. So lighting, we've considered under drawdown. Insulation, energy, building and cooling and heating buildings. Recycling, of course. Freight trucks, we already talked about it before. Agriculture and fertilizer emissions, and cement production remains the big monster in the room, the big gorilla in the room. Okay. Global greenhouse gases of global sources of greenhouse gas emissions in 2050 are expected to have many slivers left, which we will see a little bit later what they are. And obviously there is not just the solutions, innovation, research and so on, but also there is the idea of market forces, commercialization, etc. And this is from I think McKenzie from 1990, where he imagines that there is a uncertainty well, or a valley of death. Okay, so here a lot of academic research based on government and non-governmental research funding is geared towards publishing papers. So government funding for academic research typically tends to drive, as a metric, it looks for publications as a way of chalking up success of the funding. The funding manager himself or herself has to report success of the program, and that's how they do it as well. Proving sound ideas at scale to remove technical risk is where the so-called valley of death exists. This is also looked at as social distance from information production and perceived uncertainty. So people who produce information like researchers or climate modelers, climate forecasters may know the real uncertainty, but people who use it like banks, politicians, etc. may underplay the uncertainty, and people who are far away like users, let's say farmers and corporations, may see much higher uncertainty than the information producers. So this slope can change based on the context. So here, geared towards commercializing products with business risk but no technical risk, because it's already come through this transition to commercialization. Venture capital funding for proven ideas. So this is a big thing now in terms of improving efficiency of solar cells, better windmills, etc. Right? So electrifying everything is a big big part of this solution in this book. So electricity generation and other energy uses, obviously imagined with sequestration, grid electricity used for building, transportation, industry, and then energy lost in synthesis or transmission. So there is fuel synthesis imagined as well for the various sectors we talked about. So appliances, transportation, industry, and there is the energy from the sun as well. This is just an example. Burning jet fuel goes from some composition CXHY, a hydrocarbon of some sort, with oxidation, releasing CO2, water, and then losing lots of the energy. If inefficiencies are very high in this internal combustion type engines. Synthesizing jet fuel would go the other way. So you would take carbon dioxide, H2O, and electricity, let's say from carbon capture and renewable sources, and then you would produce synthetic fuel and oxygen. Of course, this would release the CO2, but again you would capture and reuse with some losses, of course. So here is another novel idea of using ammonia, so nitrogen from the air, electricity from renewables, and hydrogen from water is used to produce ammonia, and ammonia is used to transport hydrogen over long distances, where it can then be used for industrial heating or for fueling cars. Obviously hydrogen is a very light gas. Liquefying it and carrying it, etc., still requires huge amount of transportation cost, because it's not as energy dense as oil, for example. So that's a problem there. So here we're imagining here that ammonia is being converted back into nitrogen, which can be safely released, and hydrogen, which is going to be used for heating and for other applications. And of course you will have hydrogen fueling stations for vehicles with let's say fuel cell technology, which is being tested and some success is already seen. Of course, how much H2 you can carry in a car is an issue, and it is generally imagined to be dangerous and susceptible to fire and so on, but people argue that that's not the case. So maybe density is the bigger issue, energy density. Remaining emissions in 2050, of course, you have here the number of gigatons, 17 to 13 gigaton per year remaining here, and these are considered being driven towards 0 gigatons. Building fuel use, industry, escaped methane, material wastes, soil emissions, agricultural emissions, possible extra from building and transport. So there's lots of these items that will still have some emissions in 2050, which is where carbon capture and sequestration comes in. So it's good to remember that we will not probably be electrifying everything and removing CO2 emissions from everything. So temperature increase, we are very likely and almost guaranteed that we're going to overshoot not only 1.5 degree warming target but also the 2 degree C warming target with the rate of emissions we are on, unless a big game changer comes along in terms of carbon capture and sequestration or carbon capture and utilization. But by slowing warming with a slow phase-in and phase-out of geoengineering, which the other books didn't touch on heavily, other than we considered accelerated mineral weathering in drawdown, the maximum temperature reached can be lower. So at least by 2100 we can come back to the same goals. So here, ocean fertilization, additional sequestration in soils, carbon capture and sequestration, solar radiation management, and so on are imagined. So that's a kind of a very brief run through the book. Obviously you have to read for all the details. All I'm trying to do here is give you a perspective of the book compared to the details we looked at in drawdown. Okay, so I will have few more books to add to it, and then we will conclude the course as a whole.